Hi, my name is Parth, and this is my presentation on dynamic stochastic general equilibrium models and how they contributed to the crash of 2008. So before we look at these models and their contributions, we have to look at actually what happened in 2008. The Economist mentions that one of the things that led to the crash of 2008 was the bankruptcy of the Lehman Brothers. They were the fourth biggest investment bank at the time, and their bankruptcy created uncertainty and general fears about the time. Andrews also talks about a housing bubble that some economists saw coming, but nobody really understood the scope of what would ensue when this bubble burst. Along with this, the prices for houses went up much faster than inflation or disposable income. The chairman of the Fed at the time, Alan Greenspan, said he was not really worried about this because housing prices had never had a nationwide decline, and this so-called bubble bursting was not really a worry of his. The Economist also talks about how financial engineers took subprime mortgages and turned them into low-risk securities by pooling them together. Subprime mortgages are a type of loan that is given to those who have bad credit scores, and generally they would not qualify for a mortgage. The problem with pooling them all together is that pooling only works when the risk of each component is uncorrelated. To be fair, at the time, banks thought that property markets in cities would rise and fall independently, but this turned out not to be the case. These mortgages that were pooled to back the CDOs were divided into tranches by likelihood of default. Investors bought safe tranches which were rated AAA, and some entities such as the Ontario Pension Fund are only certified to buy AAA tranches. The agencies that rated the usefulness of these tranches were also often much too lenient. These securities were very appealing to investors as they provided what appeared to be high returns in a world where returns are generally very low. Another reason subprime mortgages were so popular is because Greenspan fought against regulations on them, which all in all meant that people could borrow more than they could afford. But after the crash, these CDOs were exposed to be worthless. This meant that companies that didn't absolutely have to spend reduced spending drastically to keep more cash, which in turn resulted in a problem for the finance market, but the rest of the economy as a whole as well. Now let's take a look at what a dynamic stochastic general equilibrium model actually is. Dynamic means modeling time, stochastic means with variables in the equation, general means it's applicable to many things, and equilibrium means it deals with equilibrium and the economy as a whole. Mason says that in 1970 the purely Keynesian way of thinking wasn't applicable, and economists were split between the new Keynesian and the new classical way of thinking about macroeconomics. So, new models were created that involved super abstract equations. These are equations that basically you must know the value of one variable to know the other, such as here you need to know x if you want to know y, and they rely on consistency and deal with things like equilibrium. Cohen-Seddon says the main reason that these models are used today is because they can reasonably predict a result assuming they are given the correct parameters. One assumption that they do make in these forecasts is that the future variances will be close to the historic average for, let's say, something like inflation. However, this is a big assumption that we will talk about later. If you're still confused, PW provides a very useful analogy here. There's a boat floating on the ocean, with the ocean current being the trend. The wind represents shocks that move the boat, but at the end of the day, the boat stays on track because it is being carried by the current. If we look at the right-hand side, the financial crisis changed the current of the ocean altogether, and so the one time we actually needed these navigational tools, they weren't really useful at all. Now that we've looked at what DSGE models actually are, there are quite a few problems with these models that we really need to understand before we can apply them to 2008. Cohen-Seddon talks about many of these, with the first problem being the idea that the economy is constantly changing due to shocks, but at the end of the day, returns to some form of equilibrium. This idea somewhat discredits the fact that small shocks can have a big impact on the economy, as it's saying at the end of the day the economy returns to equilibrium anyway. This idea, if you've noticed, also has two other problems. The first of these being that the economy is usually stable at equilibrium until affected by a shock. The truth is that shocks, no matter how big or small, are constantly changing the economy, and these models were built for a system usually at equilibrium, where in reality the opposite is true. We'd be lucky to see the economy stable at equilibrium, as it often is not. The other assumption that Mason talks about is that only shocks from the outside shift the curves, and shocks within the system were not really considered before 2008. Finance did not play a role in these simulations because it was considered an outside shock, but rather turned out to be an internal one. Since we're on the topic for shocks, economists actually have to plan out what these shocks do to their models. For example, if input prices rise, what will happen to aggregate supply? Now this poses an even bigger problem. If economists are coming up with cases in which their curves shift, and what these cases are, they don't actually know that they've missed a case until it comes up and their model can't do with it. New factors in the economy are constantly being created that could cause new shocks, and so economists have no way to prepare for these. Another problem is that these models work under the assumption of ceteris paribus, which means if all else is held equal. While in theory this works, in reality, history will not continue to evolve in the exact same way, and so these models can produce outcomes that are flawed. For example, in the Great Prosperity, let's say the inflation was 2% every year. The model will assume that any shifts to the curves will be at this 2% a year rate. But the second that a new regime comes in, or there's some changes in the economy and the inflation rate goes up or down, suddenly the scale and even accuracy of these models comes into question. These models essentially are unable to deal with structural changes within the economy itself. Cohen also points out that it is not okay for this model to just assume that everyone makes rational decisions. People do things like take out mortgages that they can't afford, which theoretically, according to these models, is impossible. Now more from the theory behind the models and why it's flawed to the models themselves. There usually is not enough historical data to back up derivatives, and derivatives used in these models are often not well understood. The Wharton School at the University of Pennsylvania says that in these cases, calibration is used to fix the model. What this essentially does is fix the model so that it would have calculated the data that is now being seen in real life. The errors with these models often come from parameters used to calibrate the models. Friedman references an experiment that was set up by an economist named John Carter. He took a model and set it up for a hypothetical oil field, and any data generated was true and set as the baseline. He then calibrated the model so that theoretically it would have predicted the data generated. The model is now calibrated and should theoretically give a perfect prediction. That being said, every time the simulation was run, it produced different results and had to be calibrated so that it would give the right answer once more. Now, if we take a moment to think about this, it makes sense. If our answer is 4, there's many ways to get there. We can do 0 plus 4, 1 plus 3, 2 plus 2, 3 plus 1, or even 4 plus 4 plus 0, which will all give us the right answer, but different ways to get there. A comparison was made to Newton's constant in physics, and how if you had to calibrate this every time you used it in an equation, it would not seem very reliable, and so these models should not be considered reliable as well. The Kiel Institute of Technology also says that the more sophisticated a model gets, the more easily it hides its limitations. People who create these models have a responsibility to point out their shortcomings, as they can often add to the control illusion. This is the illusion that because we are using models, we know what's going on, but people who have not developed these models often don't know their limitations or setbacks. The DSGE models might actually add to the control illusion. Mason talks about how other models might be more useful, such as agent-based modeling. This is where instead of trying to predict what would happen, you simply release artificial people into a simulation and see what happens. While the result may be more accurate, we'll save that discussion for another lesson and now talk about how the flaws in these models contributed to the scale of 2008. Many economists, including Steve Keen, attributed flawed models to the scale of 2008 crash. He claimed that statistical analysis and empirical data does not hold up in the Great Depression. One of the reasons we talked about earlier that the Kiel Institute of Technology brought up was the rise in the market and demand for CDOs. People warned us that we were using these models, but due to calibration error and parameter error, they did not prepare us for the type of risk that comes along with such widespread use and dependence upon CDOs. Others argued that it's the government's job to protect us from a system-wide failure, and so the use of these models, whether they added to or took away from the control illusion, could be used safely. Another reason that Axtell and Farmer says that these models contributed to 2008 was because DSGE models ignore key points such as the fact that people do not have infinite credit. This assumption took the idea of people being able to borrow more than they could afford that we talked about earlier, and multiplied it exponentially, which is not realistic at all. Another problem that led to 2008 was the fact that the Fed relies far too much on historical data. Structural changes in the economy make this data invalid, and so the picture it can often be seen painting is not what the model needs to predict future outcomes. The models were working on the assumption that the economy was still within the Great Prosperity. However, in reality, the market crash of 2008 made all this data invalid. Another assumption that these models did not account for was the financial market. These models just assumed that banks were not important, and moreover, with the assumption of infinite credit, also assumed that banks could not really default. And so, when the Lehman Brothers defaulted, it started providing invalid predictions for what was going on. The Wharton School at the University of Pennsylvania said that another contribution was also that economists underestimated new derivatives that were used whose values fluctuated with the value of underlying securities. Pooling mortgages to make these securities was already a somewhat new concept, and so basing derivatives and financial models off of them was even more complicated and even less understood. The people that built these models did not see it as their job to inform people of their limitations. They were more of the mindset that these models are out there and people can use them if they so please. This led to many people using these models to add to the control illusion. Rather than try and figure out the true value behind these derivatives, many economists decided it would be better just to go back to creating new financial products, and the market would naturally choose the best option. However, these models were so widely in use that they took away people's choices and everyone ended up coming to the same consensus, because they were all using the same models, and having the upsides of many participants in a market was not really utilized. This is my works cited, page 1. This is the rest of my works cited. Here's my works consulted. And I just wanted to thank you for listening to my presentation on DSGE models and how they contributed to the crash of 2008.